Hello, everybody. I'm very happy to be here in G4G. Very happy G4G is back. Very sad I'm not there with you in Atlanta. So I would like to talk a little bit about this work I made with my colleague Pedro Freitas from the University of Lisbon as well, about the first book written, printed in mathematics in Portugal, roughly 500 years ago, in 1519. This is my colleague, and these are two illustrations of two problems in the book. As you can see, they are Pythagorean theorem problems, but the book is much more interesting than that. So this was a book for to teach mathematics to people for the trading, mainly. This kind of book was popular around this time in Europe. But what is interesting about this particular book is that it contains, besides the arithmetic that was common, like multiplication tables, multiplication algorithms, the division algorithms, and so on, it contains several useful things for trade, like fractions, percentages, proportions, and so on. But it also has a big collection of problems that we now classify as recreational problems. And these problems, of course, have genealogy. Some of them can be found in books that have been around for a long time. Some others are original. It's very interesting to look for each particular history of each particular problem. And this is the sources we used, of course, guided by David Singh Master, of course, the master in history of recreational mathematics. And we found, I have some to share with you, some problems. You can do snapshots and think about them later. This is a very nice problem called the monkey and coconuts, the kind of problem. Of course, it's already in Fibonacci in 13th century and so on, but it is a nice implementation of this problem. The solution is very easy, and I won't bother you with that. Some problems are sophisticated, like this one. It's not usual to find this kind of problem in recreational collections. Two numbers in which the sum equals the product. It has a flavor of real mathematics, and the author gives a nice general solution. If you find a number that is equal to the sum of two other numbers, then C over A and C over B work. Their sum is their product, equals their product. It's a very nice thing. Another problem that looks like problems from Diophantus. It's not exactly, but it really has the same flavor. To find a number that if you add 10, you have a square, and if you take away 10, you also get a square. And this is not in Fibonacci, Pacioli, and so on. And the author, Gaspar Nycolas, gives a nice general method to do it. If you take an even number and you construct n even and you construct m as an auxiliary constant, then you easily do this trick and you get two numbers that work. One minus the other is a square, one plus the other is a square. This is a particular case for 26 and 10. It's a very nice number. Well, we have Chinese remainder theorem. That's a must in all recreational collections. These problems are very old. Of course, they didn't have the Gauss notation or formalization of the congruency, so this had to be done with fantasy, so to speak, and it's done with fantasy. Those are difficult problems. Some problems can be approached today as linear systems, but linear systems like this one, that is also very old, for instance, is a complicated system with 4 equations and 4 unknowns, but the particular phrasing of the problem makes it very easy to solve even in your head if you have the right approach. If you add all the equations, you see that you get the 3 times the total amount, and then it's very easy. So it's elegant, it's kind of nice. This famous problem of the weights, which is already considered in Fibonacci, Choquet, Pacioli, 3 weights that you can use in a scale balance to solve all the weightings until from 1 to 40 is a very nice problem. And the way it is phrased looks original according to our sources. And it's funny that Choquet, for instance, says, gives a solution method, start at 1, double the sum and of the previous ones and add 1, while Pacioli writes it in a different way. So they start at 1 and multiply by 3, which is equivalent. And our Gaspar Nycolas just says, use fantasy, which is a nice way to put it. Because this is one of the problems that he shows, that he cannot give a method to solve. Okay, so I think I'm running out of time. So I invite you to see these problems. We made a actual edition of this book, and whoever is interested, we can share these books with you. And well, I hope to see you in our Gathering for Gardener in Portugal in January. Tiago is over there, he can show you the details. And thank you very much.